Hey everybody, so we are going to work on a new project here, and this project is something that I've been working on with Brendan. And what we discussed initially was that I wanted to create a very special sound pedal for my bass. Right? All of you know that I'm a musician and I play the electric bass and I'm in a band and stuff, and you know, one of the things that I wanted to do as a project was come up with a pedal that I'm interested in. And you know, although I'm a bass player, one of the things that I enjoy about playing the bass is that sometimes you don't just play bass, you play rhythm. And you can play lead, and you can play all kinds of things with bass. So one of the things I'm looking for is a really gritty, almost trebly sounding bass that I can dial in when I need to. So Brendan and I have come up with an initial design, and I can guarantee you this won't be the final design, but this is the design we're going to start with. And just to kind of orient you with how it works, here's the input, here's the output. So you plug your bass directly into in here. It goes through this series of capacitors and potentiometers and comes out the other side over here and goes right into your guitar amp, or your bass amp in this case. It's a relatively simple circuit, but there's obviously things that you have to consider. So for example, it comes in on the input and it comes around here to a 270K resistor, goes through two different sides of a capacitor, 0.018 and 0.0018, and there's a 500K pot here that controls that. And then over here on the treble side, it goes through a 330 pico cap, a 33K resistor, and a 0.0033, and again another 500K potentiometer right here. Over here we have a pair of red LEDs, and the LEDs are not going to light, they're going to act as diodes. Okay, and we'll talk more about that when we get to it. And then lastly, we have a 1 meg pot here, which essentially creates the distortion. So this is what we're going to build. Now let's talk a little bit about how this kind of works, right? So so if you think about the way that a tone circuit works, okay? So if you've ever seen a signal going through an amplifier, you'll know that you usually get a sine wave like this, right? And you usually will see, if you overdrive that circuit, that's what you call breakup. And if you overdrive the circuit enough, it actually turns into a square wave, like that. It'll flatten out these sides and it'll flatten out the top. All right, that's how this stuff works from a signal perspective. This is mostly true when you measure guitar amplifiers and bass amps and check to see if they're performing correctly. But you also know that a tone circuit also robs you of power. So all of these things that we're talking about here take power away from the amp. Now this particular pedal that we're dealing with here is not powered. So that's design number one, is that it has no power. And we're going to see how much power it really steals. And we're going to experiment with the settings, because it depends on how you turn these potentiometers, how much it's going to steal. And there is a calculator that you can use to kind of gauge this, and I'll walk you through that when the time comes. So that's essentially how this works. So it's just like a tone circuit in a radio, right? A tone circuit is going to eliminate high frequencies or low frequencies. And in doing that, you steal power. So back to our design, how are we going to do it? Well, we're going to use some breadboards. We've got a couple of breadboards here. Let's pull the shot back. We've got a couple of breadboards here. We're going to use these. And we're going to create a test bed in order to do this. And here's the test bed that we created. So basically it's a project box. And I've got my 500K pot here and here. One for bass, one for treble. I have my output. I have my input. And then I have the fuzz button right here. So these two wires right here go to the bass and the input. Okay, the input is the yellow and white, and the potentiometer are these three. And then on this side, treble right here, and output. This is for our output right here, and this is for our treble knob. And then these two wires that come out here are for the fuzz. So we should be able to connect these things onto a breadboard and be able to plug a guitar into this and play with it and test it, right? What we're going to do is we're going to put it on the scope. We're going to observe some differences. We're going to put an audio frequency generator through here, and we're going to observe what we see. And then we're going to make a determination. We're going to put it through an amp and see if we can actually hear anything different. So if you're interested in something like this, stick around. We'll probably do 2 or 3 episodes of this one. But we're going to dial it into something that that I definitely am into. And then I'm going to build it. So I'm going to buy, a blank pedal, and I'm going to build the circuit card. That's my plan, is to create the circuit card myself. You've seen me do that before. Mount the components, mount it inside, and then I have a pedal I could use on my pedal board when I gig. All right, so that's the plan. So I'm going to cut the camera off here, and first thing I'm going to do is I'm going to build the circuit here as you see it, and we're going to show you what that looks like, and then we're going to start to run some tests. Okay, be back. Okay, so we've built our circuit on a breadboard, and I hate breadboards, by the way. So they're really, for me anyway, I have a hard time getting them efficient and having the least amount of wires as possible. But we built our circuit on a breadboard, and it works, but it just steals too much power. The amp puts out 0, basically. So what Brendan suggested we do is we add a power supply to it, and you heard me mention that earlier. And what we're going to use here is an LM324 to do that. So it's very simple. So the output from the tone circuit that I showed you will actually come in here. So the out goes in. It comes along here to a 1 meg audio taper pot, which goes into pin 3 of an LM324. That's the positive side. The bottom side of this goes to a ground rail, and you'll see the ground rail comes across here. This LM324 is a good chip. It actually has 4 amps built into it. We're only using 1. Okay, so the output on this chip is pin 1, and your power comes in on pin 4 and pin 11. All right, and your input comes in on 3 and 2. So really simple chip, very cheap, also easy to blow out. Right, so you got to be careful how you wire these things. So essentially, you're going to power it with 9-volt battery. Comes in here through pin 11 and pin 4. And it's going to amplify what comes out of your tone circuit, which is exactly what we want. And then we put a 4.7 microfarad cap here on the output. This is going out to the amp right here. And all that does is really just smooth any errant noise and static and hum and all that stuff. So this is our circuit. It's relatively simple. Got a pair of 4700 microfarad caps, 4.7 resistors. We got a pair of resistors here, 10K and 100K, and we've got our pot. So we've essentially built this, and I decided not to use a breadboard because this just made it even worse. So what I did was I took the design and kind of transferred it to this document here, and this shows the entire circuit that we're working with here, with the exception of those diodes that I told you about, and I'll explain that in a moment. So here's our tone stack, all right? So you're coming in here. Here's our 2 pots, our 500K pots. The signal comes out of this stack, comes over here, and then goes into this LM324 circuit that I showed you just now. And you've got a 1 meg pot here that lets you control the volume and the power that comes out of it. And it will go through this chip and come out right here. And it works. So we built it. So we've tested it. However, when I installed this part of the circuit right here, which are the 2 diodes, which is experimental, by the way, and this 1 meg pot here to control the fuzz, doesn't really make a difference at this point, so we're going to have to experiment a little bit more on that. But in theory, we have this thing built. So let's take a look at it. We'll let you see it. I'll walk through it in person. And it's right here. And here's our circuit. And we'll zoom in so you can see it. So here is where our bass goes in. Comes in through these 2 tone controls, just like I showed you in the diagram. Comes out and goes to this 1 meg potentiometer, which lets you control the volume coming out of the amp. Here's the LM324. Here's the pair of capacitors and resistors, and then here's the output. Here's the battery clip. And these are the 2 diodes that I told you about, which should, in theory, allow you to fuzz it up, but we're going to have to play with that. That doesn't really work well. So what we're going to do is we're going to put an audio generator through this thing, and we're going to connect it to the scope, and we're going to see what the controls do, and let you see that. All right. So let me set that up, and I'll come back and show you what that looks like. Okay, we're going to start measuring this thing. Just to set up the shot, I've got my oscilloscope connected to the output, and on the input I have the old Heathkit audio generator connected. And what we're going to do is we're going to fire it up, and we're going to go with probably 1,000 hertz signal, and we're probably going to go at 1 volt output voltage, and we're going to see what we can make this thing look like here. So let's focus in on the scope right there. Let's power up the audio generator. Remember, this is an old one. It's got tubes, so it takes a minute to warm up. And there we are. You'll see peak to peak, we're 920 millivolts. I'm just going to bring that voltage up just a little bit. I want to get it about 1 volt. A little high there. There we go, 1 volt, right on the nose. Okay, so essentially what's happening is I'm putting a signal in through the tone stack, and then it's going through the LM324, and it's coming out the other side. Real simple. First thing we're going to do is we're going to exercise the 1 meg pot, which you will see right here. Where's my hand? There it is. There's the 1 meg pot that goes into the LM324, and we're going to watch what happens to the signal. So you see, as we turn the potentiometer, we basically cut all the power off, which is good. That's what we want. So right now that's maximum power. Okay, we're going to leave it wide open, maximum power, for the experiment. So we know that the pot works, right? And we're controlling the amount of power that this thing puts out, which is a good place to be. First thing we're going to do is we're going to turn the treble control. All right. Now, what you're observing there is basically stealing power. So as we turn the treble control, the wave gets smaller, right? So why is that? Well, as you strip out frequencies, bass frequencies, you're also taking some of the power with it. So that's why our LM324 is there to help compensate for that. So you're observing, as we turn the tone control, exactly what we said would happen. We would lose power. Let's bring that wide open. Now we're going to touch the bass control. All right, and you'll see what's happening there. Our wave is shrinking a little bit, and what we're doing here is stripping out high frequencies of the frequency spectrum. All right, and it modifies the amount of power this thing puts out. So really what we're demonstrating here is that the amp, the tone circuit that we built for our pedal is working, and we're able to see the effects of turning the knobs. I'm also going to turn the knob on the fuzz control that we put in there, which was the 2 diodes, and I'm turning it, and you'll see it really has no bearing at this point, so it's not doing what it's supposed to do. And as I said earlier, Brendan and I discussed that this was experimental, so no major disappointment here. We just know we need to do something different. All right, so let's bring the power down a little bit and see what effects we have on our tone circuit. Again, you know, it's all relative, right? More power, it's all good. So we know that the LM324 is working, and we have 4 other amps in there that we could use if we had to. Not necessary for this experiment. So I think we're in good shape, and we're going to go on to the next part now. Be back. Okay, for the next part of our experiment, we're going to focus on the fuzz section here. So you'll notice that I have the 2 diodes, and they're piggyback basically, and they go to a 1 meg pot. And if you remember this diagram here, they go to the output. But because we've added this amplifier section, right, the output goes into the LM324. I've had to move these diodes here to this output section. So basically it comes after the 4.7 microfarad cap and goes to the ground bus. So I've got that there. I've also added a 100K resistor across that output. So so what we have here is we have the scope connected to the positive side, and we have the other side of the lead that goes to the output. So let's take a look at the scope and see what we get. So right now I'm putting the same signal through there that I mentioned earlier. It's 1,000 hertz, and it's relatively smooth. Now when I turn the pot on the fuzz control, you'll see that it is doing something. All right, so I'm actually reducing the signal to 0 here. But what I'm not seeing is the breakup of the sine wave. So what I would expect to see happen, if this was working correctly, is the top of these sine waves would flatten out like this, and it would actually turn into a square wave. That's an indication that the signal's breaking up. So we're missing something else. I'm going to have to talk to Brendan about this, because I think what we possibly need to do is utilize one of the other amplifiers on the LM324. There's 4 of them on there. We're only using one. We may need to wire into that and drive a little more signal into this circuit in order to get this to work. But I'll talk to Brendan. He knows a lot more about this than I do. I'm just the student here. So so this is working, right? It's doing its job, but not quite enough. We need a little more oomph out of this thing. And if I modify the amp volume using the LM324 that we put in place, it doesn't really do much. So that's why I think we need to expand on that a little bit. But we'll get there. So we're still learning. So I think what we'll do here is we'll end this as our first episode, because we are still going to play with this thing a little bit. And I'm going to include a little bit of a video right after this part that shows you exactly what kind of sound I'm going for, and you'll have an idea. All right, here's that video now.
Player. Well, I suppose guitarist.
They lived.
Okay, so in episode 2, we're going to come back and look at the progress we're making, and we'll see if we can dial this thing in a little bit better. If you have any questions, let me know. I can basically explain this thing very minimally, but I can do it. And I thank everybody for watching. Take care.